Hey guys, welcome to day 3 of speed. We are going to be doing more of the same of what we've already been learning, but today we're going to be doing some word problems that are a little bit more complicated, okay, where we're going to have to think a little bit harder. Okay, let's start off by drawing the speed triangle. Go ahead and copy this into your notes. Make sure you have the division signs and the multiplication signs. Okay, and then from memory, progress to number 2 and write the distance formula, the speed formula, and the time formula. Okay, let's check those and make sure you got those down. Distance equals speed times time. Time equals distance over speed. And speed equals distance over time. Okay, let's do some word problems. John started cycling at 7:30 a.m. By 9:30 a.m., he had covered a distance of 20 miles. Find his average speed in terms of miles per hour. Okay, our first step, of course, is to label the problem. So we're trying to find speed, right? So let's do speed equals question mark. Our distance is 20 miles. Our time is right here, isn't it? And it doesn't give us a number of hours. It just says he starts at 7:30 and by 9:30 he had covered a distance of 20 miles. So we need to use our brains and conclude that John cycled for 2 hours. Because if he started at 7:30 and by 9:30 he will have cycled for 2 hours. Okay, so now let's use our formula for speed. So speed equals distance over time, and plug in our variables. Our distance is 20 miles and our time is 2 hours. So our speed equals 10 miles per hour. All right. Okay, now your part B says that if he cycled a further distance of 15 miles at the same speed, what time would it be? Okay, so it's not asking us like how much more time he cycled, it's asking us what time would it be. So first of all, we need to find out how much time he spent cycling, right? So time is going to equal distance over speed. It says here in my problem that he cycled another 15 miles. Oops, I don't want to write a D there, I want to write a 15. So he cycled another 15 miles, and it was at the same speed, which we found out was 10 miles per hour. Okay, so our time is going to equal 15 divided by 10, which is going to equal 1.5 hour. And how I got that was, whenever we divide by 10, so if I have 15 divided by 10, I'm going to assume, in 15, my decimal point is right here. If I'm dividing by 10, all I have to do is move the decimal point. I don't have to really do any actual division with that. I mean, I am dividing, but that's a shortcut. So our time is 1.5 hours. That's how much time he spent cycling, that additional 15 miles. However, that is not what time it is, right? In part A of that problem, we read that John finished cycling at 9:30 a.m., right? He started at 7:30. He finished at 9:30. And then he decided to bike another 15 miles, which took him 1.5 hours. So we need to add an hour and a half to 9:30. So if we go from 9:30 and we add 1 hour, it's going to be 10:30. And then we add another half hour, and it's going to be 11 o'clock. So he is finished cycling at 11 o'clock a.m. See if we can get my pen to stop freaking out. There we go. Okay? Okay, go ahead and try this problem, both A and B, on your own. I'm assuming that you have notes at home and they're following along with those, but go ahead and try both of those and come back and check your work. Pause the video. All right, let's do this together. So Paul started rollerblading at 5 a.m. and by 7 a.m. he had covered a distance of 12 miles. Find his average speed in miles per hour. Well, the first thing we have to do, of course, is to label our problem. So 12 miles, I'm going to put a D above that for my distance. I'm going to put an S with a question mark above speed because we don't know that yet. And I'm going to look up here, and it doesn't give me the amount of time, it just gives me the times he stops and starts. Or, well, I guess it's not, it doesn't say he stops at 7, but that's fine. So time, if he started at 5 a.m. and then at 7 a.m. he'd covered a distance of 12 miles, that's going to be 2 hours. And we want to find his speed, so let's use our speed formula, distance over time. So 12 miles over 2 hours, and 12 divided by 2 is 6, and our unit is miles per hour. Okay, so that's our average speed. So that's our answer for letter A. Let's skip down here now to letter B. Okay, and it says, if he rollerbladed another 18 miles at the same speed, what time would it be? And so remember that Paul was traveling at 6 miles per hour. So let's figure out, first of all, how long it takes him to travel that amount of time. So time equals distance over speed. And our distance this time is 18 miles, and our speed is still 6 miles per hour. And so our time equals 18 divided by 6, which is 3 hours. Okay, so we want to find out what time it is, right? Oh, I shouldn't have boxed that because that's actually not the answer, is it? So he started at, let's see, well, we can go back to 7 a.m. because at 7 a.m. he had already biked for 12 miles, and we're just measuring the time between 7 a.m. and whenever he's done. So we want to find out when he's done. He biked another 18 miles during this time, which took him 3 hours. So 7 a.m. plus 3 hours is just going to be 10 o'clock a.m. And that's our answer. Okay, so number 5 says that Colin took 4 hours to drive from town A to town B at an average speed of 75 kilometers per hour. Find the distance between the two towns. That's the first part, and then letter B, it says that on his way back he drove at an average speed of 60 kilometers per hour. And then we want to find out how much or how long it took him. So let's just deal with part A for right now. Let's label our word problem. And our time is up here, 4 hours. Our speed is 75 kilometers per hour, and we put D with a question mark because we don't know the distance. So we're going to go ahead and use our distance formula. Distance equals speed times time. Then fill in the variables. Distance equals 75 kilometers per hour times 4 hours. And then we're going to multiply that out. And if we multiply 75 times 4, and do my work over here in the corner, we're going to get 300. So 4 times 7 is 28, plus 2 is 300. Okay? So let's take a look at part B now. So if he drove back at 60 kilometers per hour, how long would it take? Okay, what's our distance? We just found it out in part A. So let's go ahead and write it here. Our distance, remember, was 300 kilometers. So let's use our time formula. Time equals distance over speed. And our speed now is 60 kilometers per hour. So you should think through, will it take him longer or will it take him a shorter amount of time to get back? And let's go ahead and divide that. So 300 divided by 60, let's go ahead and cross cancel there, and we're left with 30 divided by 6, and our time is 5 hours. So it clearly takes him longer to drive back at a slower speed. Okay, so this next one's pretty complicated. And you'll notice that I have some different things labeled up here. I've got a T1, an S1, an S2, and a T2, okay? And I've already got some things written down here over on the side of my notes, and I'd like you to copy these down as well. All right, so Sarah took 3 hours to bike from point X to point Y at an average speed of 20 kilometers per hour. On her way back, she biked at an average speed of 30 kilometers per hour. How long did the trip home take? Okay, the reason I'm keeping track of this over here on the side is because we have so many different variables to keep track of, and we need to stay organized with those. So I'm going to require that you guys do the same thing on your notes, okay? So this problem is first asking basically, how far, or how it says how long did the trip home take, but we don't know how far she traveled. So obviously we have to find that first, right? So we have our T1 and our S1, so we can find that distance. So let's go ahead and use our distance formula and plug in our numbers. We have 20 kilometers per hour times 3 hours, and we're going to find that our distance is 60 kilometers, and we can actually write that in right here. Okay, so 20 times 3 is 60 kilometers. Okay, so we already know that they have 60 kilometers, or that she traveled 60 kilometers, and we need to know how long it took her to get home. So let's use our time formula. Our T2 we don't know yet, but we do know our speed 2. It's 30. Oh, my pen's not working here. But you guys should write that over here in your chart. 30 kilometers per hour. And so we're going to use the same distance. She didn't travel any farther on the way home, so it's still 60 kilometers. So we plug those in, and it's going to take her 2 hours to get home. All right, you guys, that's it for today. I'm not going to demonstrate the rest of these problems because they're very similar. So if you use the strategies that I've showed you, you're going to be fine on those. All right, have a good night.